In this video, we are going to talk about inverse relations. Inverse relations are a relationship where you will see some sort of relation flipped over the y equals x line. So this dotted line right here, this is just y equals x, or you might know it as the linear parent function. And so an inverse is when you take whatever function you have and you reflect it over this line. That could be known as switching your x and your y coordinates. So if we make a list of these coordinates and we switch them, we can find what the reflection is. So this ordered pair right here looks like it's 0, 1, which means that for my inverse, it's going to be 1, 0. And we could go ahead and draw it right there. And look at that. That looks like a pretty good reflection over that line. It's equal distance away on either side, and it looks like just a pretty good reflection. This ordered pair looks like it's 1, 2. And so if I were to flip that, that would be 2, 1. And we can go ahead and graph that as well. 2, 1. And look, again, that looks like a pretty good reflection over that line. And they look equal distance away. Now we have one more ordered pair, and that ordered pair looks like it is 2, 4. And so if we flip that, we get the ordered pair 4, 2, and we can go ahead and graph that. 1, 2, 3, 4, and up 2. And look, again, it seems to be equal distance apart. So now we just want to mimic this shape on the other side. Well, this looks like it's getting as close to 0 as possible without ever actually touching it. And so I feel like it should go up as close to 0 as possible without ever actually touching it. And there we go. There's our inverse relation. Now there's a couple of really cool things here. If we talk about the domain and range of our original, well, our domain is going to be all real numbers. So x such that x is an element of real numbers. Because there's not a single x value that we could not plug into this. The arrows indicate that it's going to go on forever. And so that's going to be our domain. Our range, well, it doesn't hit 0, but it is every number above that. So y such that y is greater than 0. Let's talk about our range for this guy then. Well, and our domain and our range. Our domain, well look, it doesn't look like it ever reaches x is 0, and it's nothing below. So our domain is x such that x is greater than 0. Our range, it appears, well, the arrows are going forever. It appears our range is all real numbers. Let's compare our domains and ranges. Domain of the original is all real numbers. Domain is x is greater than 0. Range of the original is y is greater than 0. Range of our inverse is y is an element of all real numbers. Huh! I see a relationship here. These switched places. And that makes sense because we switch places for our ordered pairs. So that's how you could graph an inverse relation. Let's think about if we have an equation. So let's start with just y equals 3x. Well, if I want to find the inverse, I swap my x and my y. So if I want to find the inverse, I'm going to swap my x and my y. So I'm going to have x equals 3y. Well, I want to solve this so that I have y by itself. So I'm going to divide both sides by 3. Three divided by 3 is 1, so that'll cancel out. And so my inverse is y equals x over 3. Now remember, we have fancy notation for inverse. This inverse, we're going to write it as the inverse of f of x, or the inverse of y, is x over 3. So there's our inverse. And to find the inverse, swap x and y. So to find the inverse, swap x and y and solve. That's pretty cool. Let's do one that is multi-step or has multiple things happening. So let's say we have y equals 2x plus 1. Again, to find our inverse, we're going to swap x and y. So I'm going to have x equals 2y plus 1. And now I need to solve for x. So I do the reverse of PEMDAS. So I need to go backwards. Is there any adding or subtracting that I need to take care of? Oh, there is. So I'm going to subtract 1 from both sides. These are not like terms, so I keep them separate. So if x minus 1 equals 2y. Now, do I have any multiplying or dividing? I do. So let's divide by 2. And now we have y by itself. Remember, we have fancy notation, so the inverse of f of x, or the inverse of y, equals x minus 1 over 2. You could actually write this another way as well. You could write this 1/2 x minus 1/2. Both of those mean the same thing. Sometimes this is a little bit easier to understand because this is going to be your y-intercept, and that's going to be your slope. Let's double check ourselves. So I'm going to double check with the first one first, and then I'll double check the second one. So if we take our handy dandy calculator and we go to y equals, let's plug in our original 3x. Let's plug in what we're going to reflect it over, which is x, and then let's plug in what we found, which is x over 3. When I hit graph, this should be a reflection over y equals x. Can't see it very well. There we go. So the blue one was our original 3x, the red one is y equals x, and the black one is x over 3. And that looks like a pretty good reflection. So that's one way to check your answer. Let's check the second one as well. So I'm going to take my calculator again. I'm going to plug in 2x plus 1. And then I'm going to plug in either one of these. If you plug in this one, you must put your numerator in parentheses. Now we'll graph it, and let's see. There's our original. That's what we're reflecting over. And there's our inverse. And again, that looks like a pretty good reflection. These can continue to get more complicated, and you always have those same methods where you can double check yourself. But let's say we have something like y equals, let's do -3 plus 4x divided by 7. Now to find our inverse, we have to switch x and y and solve. So I'm going to have x equals -3 plus 4y over 7. Whenever you have a bar like this, saying that all of this is over 7, it's like there's parentheses here. It means that you're going to add these first, and then you're going to divide by 7. And so when we reverse PEMDAS, we want to get rid of that 7 first. So we are going to multiply both sides by 7. That'll get rid of that 7, and then it makes it nice and easy for us to solve. So the next thing that we would do for reversing PEMDAS, we have to look for addition or subtraction. We have to add 3 to both sides. These are different terms. This doesn't have an x in it, so you keep them separate. 7x plus 3 equals 4y. We need to get y by itself, so we divide by 4. And there we have it. Remember our fancy notation, the inverse of f of x equals 7x plus 3 over 4. And of course, you can check your answer by plugging it into your handy-dandy calculator. Make sure that you put the numerator in its own set of parentheses to indicate that this is a rational expression. Oops. So we'll graph this. There's the original. There's y equals x. And there is our inverse. And so again, it looks like a nice reflection.